Hey, all right. So based on what you told me, you're a little new to these questions. So I have a little bit of a, I guess we'll call it like a warm-up question. I pasted it into the window. Can you see it all right?
Yes, I can see it.
All right. So at the top there, why don't you just read through that and then, talk me through it, make sure that you know what's going on, and then we can get started with the solution.
Okay. So we have an array we'll call an array A a mountain if the following properties hold. The length of the array is greater than or equal to 3. There exists some index in the array such that it is such that everything to its left is smaller than it and everything to its right is bigger than it. No, sorry, everything to its left is smaller than it, and everything to its right
Right.
is also smaller than it. And then given an array that is definitely a mountain, so this is just getting rid of any need to return false or check that it's a mountain.
Yep. Yeah. So there
Return,
will be a solution.
okay. So return any index such that, so just basically return the index that is the peak of the mountain,
Yep.
that is that number in the center. So then
Yeah.
there's
So
the
on mine,
example.
yeah. Go
Hmm?
ahead. I was just
So
gonna
then
say I
say,
pasted an example for you.
yeah, where in this case the number 5 is the peak and that number 5 is at index of 4.
Yep.
And that is why it is returning 4. Okay. So should I start with making notes about my strategy or should I just start typing in the class?
Yeah, just kind of work through it. Like you chose Java, so I gave you a little, solution class there. But talk through how you want to go about it, and then we can jump into the coding once we agree that, on an initial solution.
Okay. So thinking just like looping through it. Check the the index right before and right after, and just make sure you'd want to check or you'd want to start at index equals 1 because you can't have anything before it. I mean, you have to have a number before it when you're checking. There's no point in starting at the 0 index. And then, because the length has to be at least 3. So, for example, if you had a length of 3, you'd start with 1, check 0 and 2, and then you'd immediately kind of have your answer if that was true. And then you would want to end at the size of, it would be like a array is called A. So A dot size, oh my gosh, A dot size -1, I believe, or
Yep.
maybe even potentially -2, depending. I'm trying to think of what's the last
Yeah,
place.
I'll give you two cases here. So now what if A equals, what about in that case there?
Okay, in these cases here, does this obey what's considered a mountain? Because for 2, there's no such value to its right that is less than, or sorry, for these mountains of 3, there's no such, for example, if you look at the on line 13,
Yep.
there doesn't obey the sequence of, if you look on line 6 where it says A of I -1 less than A of I greater than A of I +1, such a sequence does not exist in those examples.
Well, what if, look at right here. Can you see where I'm highlighting? I don't know if you can.
Yes.
So this technically would follow this part, and then this part here is kind of just not, it doesn't, because there is an index that is a peak. So maybe this, might not be the best, I guess, description, but let's assume that these are valid just for the purposes of it. So the peak of it can be at the front or the
Okay.
back.
Okay, so then that becomes a valid peak.
Yeah.
If it's a fully, so if it's a list that's fully descending or fully ascending, it's the edge is the peak.
Right.
Okay, so then we'd still want to start at 0 and then at end where the index is size -1 to get the correct ending index.
All right, cool.
Okay.
Yeah, let's just start coding this up. That looks good.
Okay. So we'd say first of 4, starting with I equals 0, and then say for I is less than or equal to a dot size of 0 -1, and then I'll go back and add the method header in just a second. And then I think you can just use ++.
Yep.
In Java. Start there, but this is going to, in this case, we're returning an integer, and we'll call this call it mountain peak.
Sure.
Which takes in an array called A, and add that up here. Just move this now. Okay. Okay, and then from here, within here, we're going to say on each iteration. So basically, if in this case, you can nest an if within a for loop, or is that just not the best structure?
Yeah.
Yeah, that's fine. Okay. So okay, so we're going to have to use I think you can use get on just an array. Yeah, so array.get of I is greater than, or in this case, we want to start with checking the left side. So this is, I think, where it gets a little interesting with this, where when I'm starting at 0, I can't check. I can't get something before it. So it's almost if the index is 0, this kind of creates like a 3 situation.
Right.
Where if the yep.
So I was gonna say, just because using the for loop there, can you think of how to do this that might avoid this out of bounds error that you're gonna get, and instead of having like 100 conditionals, there might be another loop that you can use to kind of quit out when we get our solution.
Okay.
Because with the for loop starting at 0, it's gonna you can't really check for that if the peak is at index 0, and then when you get to the end, so when you get to length -1, and you try to check the condition for +1, that's gonna give you an out of bounds as well. So can you think of maybe instead of a for loop using something else?
So using a while loop instead?
Yeah, I think that might be a little bit, because that way we can quit out as soon as we find our peak. We can just keep track of an index, and if the condition, the one condition that is a peak, is true, then we can just return the index of the peak.
Okay, so changing to a while, then we're going to want to increment at the bottom instead. Yep. So basically, while just keep our condition in there, and then just say basically while I is less than or equal to the size -1, we want to, to be completely honest, we learned the
So
We
what I was gonna say
literally
is, why
learned
don't?
while loops this morning. Like
Oh,
I,
really? Okay.
yeah, like
Well,
literally
why
like two
don't we
hours ago.
put? I'll put it here. Whatever the condition is that makes this a peak. So comparing something like maybe this to that. Why don't
Hmm.
you put that in the while loop? Because as soon as that condition is no longer true, then we know that we have our peak. So you basically the comparison you're making within the array here. If you put so in this case here, right?
Hmm.
The one we have. So when do we want to break out of this and return 5? I think if you can write that as a condition inside this while here, I think that'll be all you need.
Okay. So basically while the a dot get of I, so basically getting the current index. So while this is less than or equal to I plus 1,
Yep.
then we're going to do this. And then when
Yep.
it quits out, we're going to return I.
Right. So now the only thing I think that's missing is just to initialize I there because we previously had it initialized in the for loop.
Oh, exactly. So just initialize it. And all my spacing is all
That's all
weird
right.
now. That's okay. And then so basically int I equals 0 to
Yeah.
start.
So let's run through some of the examples and we'll make sure this works.
Okay.
We can't compile and run, but we can manually go through and kind of run through it and talk it out.
Okay.
So why don't we start with line 14 because that seems to be the easiest there.
Okay. So for line 14, it is going to, of course, initialize it to 0, and it's going to go through, it's checking where while it is less than. So it's going to go all the way to the end and return 3.
Yep. And then I think I'm not sure with Java, but you might need to have like a check here that says like and or whatever it is in Java. This you know I is less than a dot length -1 maybe. I could be wrong, but regardless, yeah. Let's assume that this worked. You had it correct before, and then
Okay.
so now let's check 13 as well.
Yep.
So
So
that returns
13. Yeah, 13 will, the first check will happen where it immediately just checks 3 versus 2. 3 is not less than or equal to 2, so it'll immediately end the loop and return 0, which is the
awesome.
index of 3.
Yeah, so I think this solution you have, I mean, you came to it pretty quick. I think the for loop kind of got you, but
Yeah.
so this works, I think. Again, we can't compile it, but I'm pretty sure this is a valid solution. So now I don't know if you know much about complexities here, but what would be our time and space for this solution here? And I know it's new, so if you want to try your best and we'll see what you get and then we can talk it through.
Okay. So I know because it's passing in the array A of some kind of some length n, that it has the time has, well, I think the time has something to do with that, where basically the worst case scenario would be if you had to iterate, like for example on line 14 we end up
Right.
with the worst case scenario where we have to iterate through the entire array to get our answer.
Yep.
Where I think it's big O parentheses n.
Yeah, big O of n. So that's basically just
Okay.
says that the worst case scenario is we have to iterate n times,
Okay.
assuming n is the length of the array. And then what about space here?
For space, would it just be constant?
Yep. And why do you think it's constant?
Because we're just passing in an array and returning a simple integer. There's kind of nothing else going on beyond that.
Yeah, so
There's
we're
nothing
not
that's being
adding any
created,
space.
really.
Exactly, yeah. So we're not adding any space on order n. So yeah. All right. So this is the sort of brute force solution, right? So we get O of n runtime, which is pretty good. So I think instead of coding this up, why don't we just talk it through? Can you think of any way that we might be able to increase this runtime and keep our space constant like this?
So to keep, it would just have to be basically then a faster way of going through the array instead of going from one side all the way to the other side. So I've seen before briefly a binary search. So starting at the center of the list and then kind of applying the same logic on each midpoint, and there we see of each midpoint of each list, and then continuing to cut it down that way. So for example, on line 11, I'm not quite sure how many this is in length. 1, 2, 3, 4. It's 15, so it'd be 1, 2, 3, 4, 5, 6, 7, 8. So this 2 would be the center.
Yeah.
And then, can you see where I'm highlighting?
Yeah, I can see that.
Okay. So I think that would be the center. So then taking from the center here and then establishing and running the check on the center and then figuring out which direction that we have to move in. So in this case, we'd see that 2 is less than, well, it would probably be flipped, where 2 is less than or equal. 2 is less than or equal, is not less than or equal to 1, but it's less than or equal, it's not less than or equal to 1. So then we'd want to work with this side of the list because we know that the peak has to be somewhere in this direction. And then we check whatever the center is here and then so on.
Yeah, that's the quicker solution. So for this one, this might be a bit of a challenge question. With the binary search solution that you just came up with there, what's going to be the time? And then we already said that the space is going to stay 1 or constant time. So then what would the time complexity be with the faster approach? Knowing that you're cutting it in half each time.
It's cutting it in half each time. So if it's cutting it in half each time, would the worst case scenario still be that you have to go through half of the list?
Yep. Yeah, but the divide by 2 is and then, if you haven't learned this yet, that totally makes sense. But the dividing things by 2 every time, as a worst case solution, there is I guess a mathematical representation in runtime of how you can say that.
Okay. Yeah, I haven't seen that yet.
So let's just say we had, how are you with powers of 2?
Okay, I think.
Okay, so then 4 is what?
Yeah, 2 to the power of 2.
Power 2, 8, 16, and 4. So in this, looking at this, and now again, this is like some math stuff. I don't know if we can go into it, but how do I say what power of 2 is 16? How would I do that in math?
What power of 2 is 16?
Yeah, so if you have to like cancel out exponents and kind of go the reverse way. So you would say something of 16 equals 4. What is that something?
The root?
It's log. So log base 2. Yeah. So
log base 2.
Whenever you're doing these cut by 2 things, so because it's log base 2 of 16 is 4, right? So in this case, we would only have to run through, maximum 4 iterations, probably 3. I could be wrong with the rounding, but
okay.
But yeah, so I mean, you did get the divide by 2. I know you haven't done this yet, but yeah, overall, I think you did well considering that this is like your first technical interview ever.
Yeah.
Really good job though. Yeah, do you got any questions?
Just in general of kind of like what to really kind of focus on in the future, I guess, and kind of making sure that those are the things that I can kind of continue learning, because like you said, this is kind of like my first experience doing
Oh no,
this. So
absolutely, yeah.
just,
So I think aside from like the the classic study algorithms and data structures and runtimes and things like that,
hmm
the fact that you kind of use the scratch pad is really big. Believe it or not, a lot of times when you spend so much time doing these problems and studying, a lot of times people try to memorize things.
hmm
But if you every time put some examples like I did here for you, and then you write your like pseudocode out, that is going to give you more points than coming to a good solution. Because remember how when you first wrote your pseudocode here, I was like, oh, what about this solution? And I had my description was a little bit off, so that way we kind of got on the same page.
hmm
So if you just jumped right into coding and we weren't like, say the interviewer had a little mistake where they, like I did, where this didn't really make total sense, um, the whole time I could have been thinking that this is a valid solution, but in your head you didn't think it was, and then ultimately because you just started coding right away and not explaining, you, in my eyes, would have gotten a wrong solution. Does that make sense?
hmm
So
Yeah.
that's, I think, the most important thing that I always tell everybody is to just make sure that if you're doing these two-way calls and you have this code pair in front of you, that you
hmm
write your stuff down to reference in the future, um, and then using it as a scratch pad. But in terms of like the technical part that you can focus on, I think runtime is huge.
Okay.
Knowing basically the trade-off between time and space, where a lot of times to increase runtime, you want to increase space, or
hmm
decrease runtime, increase space, and vice versa. So other than that, it's really just going to come down to just making sure all your data structures and stuff like that are all set. Um,
hmm
but syntax wise, I'm not sure if arrays are defined like this, but again, I'm not really a Java person. So syntax should kind of just be second nature, but it doesn't seem like you have an issue with that.
Okay.
So yeah, those are the main things. Cause again, it really is like, it's clear that even though the coding might not be like that quick right now, the logic behind it is good.
Okay.
So that's arguably more important, I think, because you can choose any language that as you progress through your career that you're more comfortable with, and
hmm
it's kind of second nature. So yeah,
Okay.
good job.
Thanks.